Today, we are talking about a technology that is so powerful, it literally lets us watch our entire planet in almost real time. It's called remote sensing, and its story is just incredible. It involves everything from hot air balloons and world wars to the very beginning of the space age. So, how in the world did we go from just, standing on the ground to getting this almost godlike view of our planet? Well, it definitely didn't happen overnight. To really get how we can track a hurricane from orbit or watch deforestation happen live, we've got to take a little journey back in time. And this timeline really shows you just how far we've come. We're going to rewind the clock way past the first photos from space, past the world wars, all the way back to the very, very beginning, more than 160 years ago. Okay, so our story doesn't start in some high-tech lab. Nope, it starts with some seriously brave and, let's be honest, kind of bizarre experiments just to get a camera off the ground. This first part is all about getting that first ever bird's eye view. Picture this. The year is 1858. A French photographer and balloonist who went by the name Nadar, he floats up in a hot air balloon high above Paris, and he does something nobody has ever done before. He takes the world's very first aerial photograph. And just like that, remote sensing was born. I mean, the creativity in this early era is just amazing. Before we had planes we could rely on, these pioneers were strapping cameras to basically anything that could fly. We're talking balloons, we're talking kites, and yes, you're seeing that right, even pigeons, fitted out with these tiny little automated cameras. Incredible. So you have to understand, this whole field really grew from two big ideas developing at the same time. On one side, you had optics, the science of light itself, built on the work of giants like Newton. And on the other side, you had aeronautics, which was all about the very practical problem of how do we get a camera high enough to actually see something? For a few decades, taking pictures from the sky was mostly just a cool novelty. But that all changed when the world went to war. See, conflict has a funny way of hitting the fast-forward button on technology, and for remote sensing, it was the ultimate push. World War I was the first massive turning point. All of a sudden, knowing where the enemy was from above wasn't just interesting, it was a matter of life and death. Airplanes quickly became the go-to platform, and aerial photography went from being a curiosity to an absolutely essential tool for modern war. By the time World War II came around, the stakes were even higher. The world wasn't just at war, it needed to see more. A lot more than what was just visible to the naked eye. And this right here, this is the leap that really defines what modern remote sensing is all about. The next huge breakthrough wasn't about getting higher up. It was about sensing energy that was completely invisible to us, the things our eyes simply can't see. And that one idea, seeing the unseen, was a complete and total game changer. It took remote sensing from just taking pictures to being a real, legitimate science of measurement. So, during World War II, three absolutely key technologies just exploded onto the scene. You had near-infrared film, which could spot the difference between fake camouflage and real trees. You had thermal sensors that could find a hidden tank just from the heat of its engine. And maybe the most important of all, radar, which could see right through clouds in total darkness to map out the ground below. So the wars proved the tech worked, but it was the space race that took it to the ultimate high ground. We were no longer just taking pictures of battlefields. We were on the verge of being able to monitor the entire planet. And the pace of change here is just staggering. In 1959, we get our first kind of fuzzy picture of Earth from space. Just 1 year later, the TIROS satellite goes up, giving us our first weather reports from orbit. And then by 1972, with Landsat, we kick off the first systematic, ongoing survey of our planet's natural resources. Think about what a huge shift this was. We went from looking at single, static images to having a continuous, flowing stream of data about our entire world. This wasn't just more information. It was a completely new way of seeing and understanding the Earth. And hey, this new global view wasn't just a US or Soviet thing. India, for example, developed one of the world's largest and most advanced civilian remote sensing programs, using this tech specifically for economic and social development. Starting way back in 1975 with its first satellite, Aryabhata, India built this incredible, self-reliant network. You have programs like Cartosat, providing high-res mapping for city planning, and OceanSat, which is crucial for studying our seas and predicting weather. All of it designed to help solve real-world problems on the ground. But collecting all of this data from space created a brand new problem. How do you possibly make sense of it all? The final critical piece of this whole puzzle wasn't actually up in the sky. It was right here on the ground. Before computers, you had analysts literally poring over physical photographs with magnifying glasses. It was slow, it was painstaking work. But the digital revolution, it changed everything. Suddenly, we could process these enormous amounts of data automatically, which meant faster, way more accurate analysis on a truly global scale. And this brings us right up to today. The history we've just walked through, from pigeons to pixels, has given us this absolutely indispensable tool for tackling our biggest challenges. We use remote sensing to watch ice caps melt, to guide first responders after an earthquake, to help farmers grow more food, and to protect our most precious resources, like forests and water. So after more than 160 years of innovation, we've finally done it. We've achieved that continuous, global view. We can see our planet, and we can see our impact on it with breathtaking clarity. And that leaves us with one heck of a profound question. Now that we can watch our world change in near real time, what are we going to do about it?